Hello everyone, I welcome you all to Startup Academy, India's only exclusive coaching for ISS examination. In this lecture, we'll start with a new rule of numerical integration. In the previous lecture, we did trapezoidal rule. In today's lecture, we'll do Simpson's one-third rule. Simpson's one-third rule. Now, it is also a rule of numerical integration only, like the trapezoidal rule. Here also we divide our integral into different parts. But in in trapezoidal rule, we divide it into equal number of parts, every parts. And here the division should must always be an even number. That should be kept in mind. So in Simpson's one-third rule, the even number integral should always be there, and that is the most important concept of this Simpson's one-third rule. Now, moving forward, what is Simpson's one-third rule? If I write it directly, then from A to B, if there lies a integration fx dx, then that must be equal to h upon 3 by 1/3. You must realize that it should be divided by 1 by 3. So h upon 3 into y naught plus yn. The first one and the last one plus 4 into all the odd terms in between. 1 plus 3 plus y5 plus up till yn minus 1. That would also be odd. N is even, we know that. Then plus 2 into all the even numbers in between, y2, y4, y6, and so on up till yn minus 2. Okay, so this rule, as we state it as Simpson's one-third rule, and it is also important from your exam point of view because they might ask you questions based on this rule in the previous examinations they have asked. Now, one more thing that should be kept in mind here, in trapezoidal rule, the fx was the function of was a function of a straight line, like fx was a plus bx in trapezoidal rule, right? It was a straight line. But here the function is always a second degree parabola of uh, of x. So here it will be ax square plus bx plus c. A second degree parabola will be there. They might ask you in the examination that what is the function look like, and it is always a second degree parabola. The option might be like, the options could be like this: a, b, c and d. Option could be a second degree parabola or a straight line, a third degree parabola or hyperbola. If it has been asked for trapezoidal rule, then it is straight line for sure. And if it has been asked for our Simpson's one-third rule, then it is always our second degree parabola, which can also be given as ax square plus bx plus c. And you should also remember that all of these are quadrature formulas. Quadrature means the functions are always a function of one variable only. Here the variable is x and not more than one variable. Now let us solve one question of this kind. Then we'll move to PYQs. So if we take one question from 0 to 6, 1 upon 1 plus x square dx, and h has been given to us as 1. Okay, this is our concept. So our we can say that our lower limit is 0 and our upper limit is 6 and our h is 1. So our n will be equal to 6 minus 0 upon h, which is 1, which is equals to 6. Now we have to draw the table. So here we will place x, the values of x, and here we'll place fx, or we can also say y's, or we can also say which is equals to 1 upon 1 plus x square. So x, we have to start from 0, so it will be 0 and the difference is 1. 1, 2, 3, 4, 5 and up till 6 because the highest limit is 6 only. Now if we take x from 0, if we take here x as 0, then it will be 1. If we take x as 1, then it will be 1 upon 2, or we can write it as 0.5 instead. 0.5, 1 upon 4 plus 1, 5, 0.2, 1 upon 3 will be 1 upon 17, 0.1, 1 upon 17, 1 upon 26 and 1 upon 37. This is our table for y0, y1, y2, y3, y4, y5 and y6. All of them are given here. Now we'll write Simpson's 1/3 rule, which has been given as integration from 0 to 6. Fx is 1 upon 1 plus x square. Dx is nothing but equal to h by 3 into y naught plus the last one is y6 plus 4 times of all the odd ones in between, y1, y3 and y5, plus 2 into all the even ones in between, y2 and y4. So just replacing the values, h is 1 upon 3, y naught is 1 and y6 is 1 upon 37, plus 4 into y1 is zero point 0.5, y3 is zero point 0.1 and y7 is 1 upon 1, y5 is 1 upon 26, plus 2 into y2 is given as 0.2 and y4 is given as 1 upon 17. If we add and subtract, the final answer we get is 1.4107, something of this kind. So this is your final answer for Simpson's 1/3 rule. And here also errors are there, so you have to keep in mind not to just directly integrate and write the answer. The same goes with the trapezoidal rule and all the rules, because some errors make the answers different in every cases, and in very rarely cases the errors comes to be equal. We'll do one such question today in today's class. I hope that this is clear with all of you. Let us move to question. So this question has been asked in which the table has already been given to us, and we have been asked the integration from 3 to 12 yx dx. We have not been given the function because we have directly been given the table. We don't have to find that. So this is y0, this is y1, this is y2 and this is y3, which has been given. So the lower limit is a, which is 3, and the upper limit is b, which is 12. H, they have not given us h. but they have given us n. N you can count 1, 2, 3 and 4. So n has been given to us as 4. We can calculate h. H can also be calculated. 6 minus 3, 9 minus 6, 12 minus 9, all will have same interval of difference between them, which is 3. So this is also there. And from that n can be calculated, n is 3. N does not start from 0, we don't count 0. The highest number of y's, we take it as n. So here the highest number of y is 3. So n will be 3. Or you can do it by this also. N is equals to b minus a upon h. B minus a, 12 minus 3 upon 3, which is 9 by 3 upon, which equals to 3 only. So that also you can do. So we have found out all the things. Now just we have to put it in the Simpsons table. No need to find out n in here or h in here. H we have to find out, but no need to find n. There is no need for finding n. So let us put the values in Simpsons formula. From 3 to 12, yx dx, we can write it as h upon 3 y naught plus the last one is y3 plus 4 times of all the odd numbers in between, which is only y1, plus 2 times of all the even numbers in between, which is also only y2. Just putting the answer, h is 3 upon 3, y naught. Y naught is minus 1 and y3 is plus 3 plus 4 into y1. Y1 is 1. So 4 into 1 plus 2 into y2. Y2 is 2. 2 into 2. If I, this 3 and 3 will get cancelled and we'll get 1 here. So 1 into minus 3 plus 1, which is 2 plus 4 plus 4. And answer comes out to be 10, which is our option number A. This I have done so that you will understand the concept, and this I have done slowly. If I'll practice more and more of these kind of questions, I'll be very quick in solving them in the examination, and will solve this kind of question within 1 minute. Here even fx has been provided to us, the table also has been provided to us, we don't have to make that. They have made our work easier. Otherwise they would just have given us fx and we would have to make the table and then do all of them as well. That would require much more time than this. I hope that this question is clear. Now moving forward to another kind of question. Here we have been given an integral which has the value a, and we have to find out b by Simpson's one third rule, and a is direct integration. We don't have to find out, and we have to state whether a minus b modulus belongs to which range out of these. So first let us consider a only. A is integration of 0 to 10 x square dx. We just have to directly integrate here. So x square integration will be x cube by 3 with the limits 0 to 10. Now x cube by 3 will be 10 cube by 3 minus 0 cube by 3, which is nothing but equal to 0. So we'll ignore that, and the answer is 10 cube is 1000 by 3, which is our value of a. So first one we have calculated. Then the second one we have to divide by Simpson's one third rule into 10 equal subdivisions in the range 0 to 10. So our a is 0, b is 10, and number of intervals is also 10. So h will be b minus a upon n, which is nothing but 1. So let us make another table here. I have drawn the table. Here x will come and here fx will come. Fx is nothing but y, which is nothing but x square. So x from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And 0 square is 0, 1 square is 1, 2 square is 4, 9, 16, 25, 36, 49, 64, 81 and 100. Now these are y0, y1, y2, y3 up till y10. So just putting the values directly into Simpson's formula, the formula will be equal to h by 3. H is 1. 1 upon 3 into bracket y0 plus yn, which is 0 plus 100, plus 4 times of all the odd numbers 1, 3, 5, 7 and 9. 1 is 1, 3 is 9, 5 is 25, 7 is 49 and 9 is 81. Plus 2 into all the even numbers 2, 4, 6 and 8. So 2 is 4, 4 is 16, 6 is 36 and 8 is 64. If we add all of them, I will be getting something like 1 upon 3, 100 plus this whole will come as 660 plus that whole will come 20, 56, 56, 120 and 240. That will be 240. So it will be 1000 upon 3, which is the value of our B. Now as we see, B is this and A is this. As you can see, A and B are coming similar, which is a very rare case, and modulus of A minus B, which is 1000 by 3 minus 1000 by 3 of modulus will come out to be 0 in modulus, which is 0 only. So our answer is 0, the last part. And this is rarest of rarest cases that has been asked in the examination. They don't come equal in every case, so just don't do without calculation in the examination. This kind of questions requires time, but with practice you will have speed in your calculations. I hope that these concepts are clear with all of you, and Simpson's 1/3 rule is also clear. If not, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered, and keep on practicing these kind of questions because they will require more time than other subjects in your examination. So numerical analysis is an important part of your examination. 20 questions out of 80 comes from numerical analysis. So focus on this one as well. And the concepts are easier as compared to other ones. All the best. Thank you.
Startup Academy presents Lakshya 2027 for serious ISS aspirants.